Fasten your seatbelts. It's going to be a bumpy ride. For the most part, no one likes bumpy rides, especially on airplanes. Those rides are usually the result of turbulence from rough weather. But a small business in Virginia called AeroTech Research Incorporated has been developing technologies to help with bumpy plane rides. They're working with engineers at NASA Langley Research Center on a project to improve a pilot's awareness of turbulence in order to avoid it. The project, Turbulence Prediction and Warning System, or TPAWS, is part of NASA's Aviation Safety Program.
Turbulence was identified as one of the safety areas, not because people are being killed, but because it's the biggest source of injuries in the airline industry.
Today's current airborne radar is limited in providing information about turbulence hotspots. NASA and AeroTech developed Enhanced Turbulence Mode Radar Algorithms, or ETURB, that can give a better picture of turbulence. ETURB works by measuring air motions along the flight path and scaling the measurements to the aircraft's response to turbulence. The predicted turbulence hazards show up as purple blobs on the radar display.
It takes the radar measurement and combines it with some aircraft information, what the aircraft type is, weight, speed, etc., and then calculates the predicted loads from that radar measurement.
The purple blobs provide pilots with an advance warning of turbulence so they can take steps to go around the area. TPAWS and AeroTech also developed a technology to complement ETURB called TAPS, which stands for Turbulence Auto PIREP System. PIREPs are actual pilot reports of the weather conditions encountered in flight. If TAPS is installed on an aircraft that runs into turbulence exceeding established limits, it will generate a report.
It's processing that in such a way as to make sense of the severity of the turbulence that the aircraft's experiencing. Once that severity gets above a particular threshold, the software says, we got to make a report. And so it gathers up a number of different parameters and immediately sends that report down to the ground.
Small carets on the displays represent reported incidents of turbulence. These reports provide real-time turbulence hazard to pilots, dispatchers, and controllers, and they can be scaled to reflect the impact to an individual aircraft.
What we're trying to do is just an evolutionary step in TAPS to take what's already on the airplane in terms of the sensors and the computers and do a little bit better job of processing that information and make reports automatically.
Initially, AeroTech put ETURB and some components of TAPS on Langley's 757 aircraft and flew directly into turbulence to get measurements. After refining the algorithms, AeroTech and Langley teamed with Delta Airlines to begin using the software on a commercial aircraft. Other partners included Rockwell Collins for its radar reports and AirInc for its ground displays. To date, TAPS has been installed on over 120 commercial Delta planes and continues to provide flight reports. More airlines, at home and abroad, are now getting involved in the TAPS project, which will enable pilots to get reports worldwide. Under a Small Business Innovation Research Award from Langley, the firm continues to work with the center's engineers, pilots, and dispatchers. They're putting ETURB and TAPS on the same display, and hopefully, in the not-too-distant future, there'll be no more bumpy rides.